Hi there. Today I'm going to talk a little bit about parabolas, specifically the parent graph of the parabola. If you take a look at these two functions that I have written there, both f of x, you might be thinking, wow, maybe we should have given them different names. Maybe one should have been g of x. They are actually the exact same function right here, just in alternate forms. First of all, we have f of x equals x squared. Hopefully you're comfortable enough graphing that right now. Our set of points, if we were to graph that, we can have our input, and you can get your output. You pick an input, you plug it in, you see what happens, you get your output value. So let's say I put in -2, very common value. -2 squared is -2 times -2, giving us a +4. I could put in -1. I'm going to get out 1, 0, 0, 1, 1, 2, 4. That would give you a nice general shape of this parabola. So you can take a look at that. You can graph that if you're not really sure what is going on with that. Coming over here and taking a look at this, if we simplify this and follow our order of operations, it will take us exactly back to this graph right here, this function right here, which produces the exact same graph. First thing we would need to do is square it. X minus 0 squared is actually x minus 0 times x minus 0. Don't think you can come in and just square that and square that. That's going to get you to the wrong answer. In most cases here, you'd get fortunate and it would work out to be the same thing. X times x is x squared. X times 0, 0x. 0 times x, 0x. 0 times 0, 0. You simplify that, we are now left with f of x equals 1 times x squared plus 0. 1 times x squared is just x squared plus 0. Simplify it further. F of x equals x squared. The exact same thing, just alternate forms. If you take a look at this graph and you actually see it, you are going to have a vertex at 0, 0. Knowing that that vertex is at 0, 0, if you take a look at it, I guess I should show it to you visually really quickly. I plot my points, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. That is our parabola. That is where it turns right there at 0, 0, and it continues on up into infinity in both directions there. That is my vertex. And if you take a look back up here at this equation, we do have a 0 and we do have a 0. That can kind of lead us to the general form of this equation. A, x minus h squared plus k. That is the general form of a parabola in the parent graph form that we're talking about here. A gives it its shape. I'm going to talk about that in a moment. If you would like to find the vertex, probably one of the most important points of a parabola, you are looking here inside the parentheses and you will be taking the opposite of that h value. And you will be taking the same of that value. So your vertex will be the opposite of that and the same as that. A gives it its shape. Let's talk a little bit about its shape right now. If A is positive, your parabola opens up. Opposite of that, if A is negative, it opens down. Now we can talk a little bit about the wideness, the narrowness of this parabola from A. We need to look at the absolute value of A. If the absolute value of A is greater than 1, larger than 1, our parabola will be narrow. Looking something like that. If the absolute value of A is less than 1, our parabola will be wide and flat. Something like that. That is the information there for dealing with the parent graph of a parabola. I'm going to take a look at a few examples of that right now. All right, we have our first function, f of x equals 1/2 x minus 2 squared plus 3. Looking at that, I see that my a value is positive, so I know that my parabola opens up. I take a look at the absolute value of this. The absolute value of 1/2 is 1/2. Therefore, 1/2 is less than 1. I know that my parabola will be on the wider side. I can look at what I have here in the parentheses and take the opposite of this value. The opposite of -2 will be a +2. And then I take the same as what is trailing on the back end. That would be a 3. So I now have located my vertex. 2, 3. I know my parabola opens up and it will be a little bit on the wider side. If you're looking at this right now, you know that coming through this vertex, you will have your axis of symmetry. The parabola will be the same on both sides. So logically, I am going to take a look at this value right here, this x value of 1. If I plug that in and do the math, it's going to start to shape my graph up for me. So if I plug in 1 here, 1 minus 2 is -1. -1 squared would be a +1. 1/2 times 1 is 1/2. So now I'm simplified down to 1/2 plus 3 on the back end. 1/2 plus 3 would be 3.5, 3.5. So my value, 1, and I go up there. Okay, if I do the same thing for this value of 3, I'm going to end up with that same value of 3.5. You can do the math and you can check it out if you'd like yourself. I'm looking at it, I have now slid over 1 because I am looking to find the point on either side of this vertex. And I have jumped up a 1/2. Hopefully you recognize that I have a 1/2 sitting right there. If you slide over 1 to the left or right of your vertex, you can apply this a value to tell you how much to jump up. Then the next logical point would be 0, so if I plug in a value of 0 to see how this graph shapes up, I could also choose 4, but 0 is a little bit easier to work with. So if I plug in 0, let's see what happens. 0 minus 2, -2. -2 squared is 4. 1/2 of 4 would be 2. 2 plus 3 gives me 5. 0, 1, 2, 3, 4, and 5. There you go. We can mirror that point on the other side of it. That will start to give that parabola some shape. Sorry, my hand kind of runs out of room on this computer, so this probably won't be the greatest parabola ever. But remember, it is nice and smooth and rounded. There you go. F of x. Let's take a look at g of x now. Okay, I'm looking at my a value. It's positive. I know it opens up. The absolute value of 3 is greater than 1, so I know my parabola will be on the narrower side. I take the opposite of this, -2, and the same as on the back end, -3. -2, -3. That is the vertex of this parabola. Now, I'm going to be looking for the point on either side of my vertex to start to give it shape. Okay, I would plug in -1 to see what comes out. And if you remember what we did previously, hopefully, I'm going to be jumping up 3 after I slide over 1. So hopefully, as I slide over 1, I'm jumping up this a value of 3, so let's plug in -1 to see what happens here. -1 plus 2 is 1. 1 squared is 1. 3 times 1 is 3. 3 minus 3 gives me 0. Yes! Well, I can apply that little cheat here. If I slide over 1 in this direction to find the point just next to, one lattice point over from my vertex, I'm going to be jumping up 3. There we go. That will start to give your parabola shape. If you want to plug in 0 to see how it shapes up, we can do that. 0 plus 2 is 0. It is 2. 2 squared is 4. 4 times 3 is 12. 12 minus 3 gives me 9, the point 0.09, pretty steep up there. This, as we noted earlier, is a narrow parabola. Lastly, h of x equals negative 1/4 x plus 1 squared plus 2. I'm looking at this. I see that it is a negative, so it opens down. And the absolute value of negative 1/4 would be negative 1/4, less than 1. Therefore, my parabola is wider. Find my vertex, opposite same, so the opposite of this would be negative 1. The same as that would be 2. Negative 1, 2. There we go. If I slide over 1 in either direction from that vertex, this A value will tell me how much I go up or down. So if I slide over 1 in this direction, A tells me to go down 1/4. If I slide over 1 in this direction, A tells me to go down 1/4. That's going to start to give a shape. If you want to see it shape up a little bit better, we should pick another x value to put in. So let's put in an x value this time of 1. 1 plus 1 is 2. 2 squared is 4. So now we're looking at negative 1/4 times 4 plus 2. Well, 1/4 of 4 would be 1. Negative 1 plus 2 would be 1. My next point, 1, 1. I can cheat it on this side because we have symmetry with my parabola. You can see that this parabola is definitely on the wider side. Thank you very much. I hope that helps. We will be dealing with transformations shortly.